Methane is one of the most potent greenhouse gases emitted by the dairy animals, which has 25 times higher global warming potential than that of carbon dioxide. It is reported that in India, about 50% of the total methane emission is emitted by the dairy animals through enteric fermentation. While milk production in India has to be increased, keeping in view the growing demand, it would need to be ensured that the growth in milk production is achieved in an environmentally sustainable manner. Generally, milk producers in India feed their animals locally available concentrate feed ingredients, grasses, and crop residues. Such type of feeding often results in either excess or shortfall of energy, protein, and minerals relative to the requirements, resulting into imbalance of nutrients. It has been shown that the milch animals fed on imbalanced diets produce more methane per kg of milk. Such imbalanced feeding leads up to 12% wastage of feed energy into methane, which is emitted in the environment through belching. If the ration of animals is balanced for energy, protein, and minerals, then not only productivity can be enhanced, but the methane emission can also be reduced. In view of this, large-scale implementation of ration balancing program has been envisaged under the National Dairy Plan NDP-1 for productivity enhancement in an environmentally sustainable manner. The National Dairy Development Board's laboratory is engaged in measuring methane emission from dairy animals fed on traditional diets and a balanced ration under natural conditions of feeding and management. Methane emission is measured with sulfur hexafluoride, that is SF6 tracer technique. This is an internationally accepted technique used for measurement of methane emission from ruminants under field conditions. In this technique, a small permeation tube containing known release rate of SF6 is used as a source of tracer gas. A permeation tube comprises a brass body, nut, thin Teflon, and a stainless steel frit. Filling of SF6 in permeation tube is done by cooling the body of permeation tube with liquid nitrogen . The release rate is monitored for minimum 6 weeks period at 39 degrees Celsius in the laboratory. After standardizing the release rate, a permeation tube is inserted in the rumen of an animal. Evacuated canisters connected to the capillary tubing in halter are used for collecting breath samples from the animals under study. Breath samples from individual animal are collected in canisters for 24 hours period for 4 consecutive days. Milk yield and feed intake of animals are also recorded on traditional feeding. The farmers are advised to feed the balanced ration to their milch animals for a period of 4 weeks. After a period of 4 weeks, again the breath samples are collected in canisters for 4 consecutive days. The milk yield and feed intake of animals are also recorded. Breath samples collected in canisters before and after feeding a balanced ration are brought to the NDDB's laboratory, Anand. All the samples are analyzed for methane and SF6 gases by gas chromatography technique. Methane emission is calculated as the product of emission rate of SF6 from permeation tube and the ratio of methane to SF6 in breath samples. Results of field trials demonstrate that on feeding a balanced ration, enteric methane emission can be reduced by 10 to 15% per kg of milk. Such studies on methane emission measurement help in generating data on methane emission from milch animals maintained under various feeding regimes in different agroclimatic regions of India, and reduction in methane emission on feeding a balanced ration. Data thus generated by NDDB would help in developing carbon footprint for the Indian dairy sector and in suggesting a practical approach towards methane mitigation by improving productive efficiency of milch animals. Various agencies in the country engaged in dairy development program need to share the responsibility of large-scale implementation of ration balancing program, not only for increasing milk production to meet the growing demand, but also in reducing methane emission from dairy animals, a potent greenhouse gas. Milk producers in the country also need to share the responsibility of feeding a balanced ration to their animals in their own interest as well as in the national interest.